Hello, my name is Tianyu, and this is my final project presentation for GE484 Advanced GIS. My project is about using GIS to study the 2023 Maui wildfires, especially in Lahaina. I focus on how the fire affects buildings and community services. In August 2023, a big fire hit Maui. Lahaina was badly damaged, and people lost their homes, and important services like hospitals were affected. Because wildfires are happening more often now, we need good tools to help with disaster recovery. GIS is one of them. GIS helps us understand where the fire caused the most damage and which areas need help first. It can also show where people moved away after fire. This helps with rebuilding and future planning. Other researchers also use GIS to study wildfire. Some use it to find high-risk areas. FEMA and USGS also use GIS to help with disaster response. In this project, I did four main things. First, analyze which hospitals are within or near the fire affected area. 2. Count the number of buildings by different damage levels. 3. Post-disasters priority recovery area identification and analyze. 4. Shelter site selection analyze. First, I'm going to analyze which hospitals are within or near the fire affected area. I made a 1 kilometer buffer around the fire zone. Then I use select layer by location tool to find which hospitals are inside this zone. These hospitals are at risk and may need support during recovery. Finally, I output the result and name it Hospital at Risk. The second analysis I did was to count the number of buildings by different damage levels. I used the damage data to group buildings into four types: total loss, heavy damage, light damage, and undamaged. I count how many buildings were in each group. This frequency is a number. And I also made a colored map to show this situation. Next, I performed post-disaster priority recovery area identification and analysis. I used the following two layers. One is the damaged buildings Lahaina. Looks like this. And the other is present change of population. First, I picked buildings that were totally or heavily damaged. Next, I picked areas where the population dropped by more than 10%. Then I combined these two layers. This helped me find priority recovery areas where both buildings and people are affected. Finally, I output the result and name it Priority Recovery Buildings. It shows like this is a result. Finally, I performed shelter site selection analysis. I use the following two layers. The same layers, damaged building and the road center line layer. First, I use select by attributes to filter out the undamaged buildings. Then I use select by location to select the undamaged buildings within the 1 kilometer buffer zone, fire buffer zone. After that, I use the switch selection in the attribute table to get the undamaged buildings that are outside the buffer zone, which means they are far from the fire buffers area, far from the fire area. I uh I output the result and name it Save Undamaged Buildings, and next I move to the second step. Identify safe buildings that are within 300 meters of a road. We again use the select by location tool to select the safe undamaged buildings that are within 300 meters of the road center line. Finally, I output the result and name it Final Shelter Locations. The green locations shown on the map represent the final shelter candidates. So GIS helped me understand where the damage happened and where help is needed most. To conclude my project, here are some key takeaways from the analysis. About 2,000 buildings in Lahaina were totally destroyed, mostly in the coastal and the central areas. About 2,000, no, some hospitals were inside the 1 kilometer fire buffer, showing high exposure risk. And I combined building damage and population change to find the priority recovery zones. I also select 3,862 buildings, undamaged buildings accessible. I also select 3,862 undamaged accessible buildings as shelter candidates. This shows that GIS is a powerful tool for disaster response and planning. And thank you for listening. Let me know if you have any questions.